Hello everyone, this is Dr. E, and for today we're going to be talking about joint variation, which is a type of numerical relationship that we're going to be working on in some of the word problems that I'm going to be showing in this lesson. In working with word problems, specifically in word problems that involves variables x, y, and seeing their relationship, we need to make sure that we are understanding how the variables are dealing with each other and affecting each other. And for this particular example and for our lesson for today, we're going to be talking about a different type of numerical relationship, which is the joint variation. So in this particular relationship, if the ratio of a variable y to the product of two or more variable is constant, then y varies jointly as or is jointly proportional to the other variables. And the formula or equation that is associated with joint variation that describes this particular numerical relationship is going to be y is equal to k times x times z, where k is the constant of variation or the constant of proportionality that we're going to be using to see the distinct relationship for this particular variable or numerical variable that we're working on for the lesson today. So the other types of numerical relationship that we have covered, we've had direct variation, which gave us y is equal to k times x as its equation or the formula associated for this type of relationship. We have inverse variation, which is y is equal to k all over x. And now we're going to be working with joint variation, which is given by y equal to kxz. So let's have some specific example of real life situation that gives this particular relationship, which is joint variation. So one example would be the area of a rectangle varies jointly as its length and width, because now if we want to see or compute for the area of the rectangle, it is dependent on how long your length or your width is to be able to produce our output. And in this case, it's the area of a rectangle. So notice that we have two variables that are affecting each other so that we can produce the output in this particular example. So another example of joint variation would be the amount of force varies jointly as the mass and acceleration of an object. So the amount of force is dependent on the two variables in this particular relationship, which is in this case the mass and the acceleration of an object. And another type of relationship would be the cost of your plane ticket varies jointly as the number of layover and the distance of the trip, because the how expensive or cheap your plane ticket usually is on the number of layover and of course the distance or how far you're going to fly from point A to point B that would determine how much you would pay for your plane ticket. So these are some of the example of a real life situation that we can associate joint variation with so that we will have an idea on how we will tackle word problems involving this type of relationship. So let's start with an easy one because here it says that we need to find the equation of variation. So that means we're going to be working with the formula that we are using or we have provided a while ago, in which y varies jointly as x and z, and y is 45 when x is 18 and z is 10. So that's the first part of our word problem. And the second part is to find, excuse me, to find y when x is equal to 20 and z is equal to 30. So there are two parts of this word problem. So let's work on the first part, which is finding the equation of the variation. And our clue here is that y varies jointly as x and z, given that y is 45. So that means we're going to be using the formula y is equal to kxz. And just like the previous examples on our previous topics on quantitative or numerical relationship, we're going to find the constant of variation so that we can find the unique pattern for this particular relationship. So let's start with our formula. Y is equal to k times x times z. And according to this formula, we're going to replace y, x, and z by 45, 18, and 10. So y is 45, so let's change y to 45. X is 18, so let's change x into 18. And z is 10, so we have z is equal to 10. And now we're looking for k, or the constant of variation. And by just doing basic mathematics, we know that we'll have 45 equal to k times 180. And by dividing both sides by 180, we'll be able to have the constant of variation, which is 45 over 180, which we can simplify because we know that 4 times 45 is equal to 5 times 9, and 180 is 18 times 10, and 18 is 9 and 2. So let's say we have 9 times 2 times 10, but we know that 10 is 5 times 2, so 5 times 2. So this is how, or the technique I use when I am simplifying fraction. I factor out my numerator and denominator, so I can cancel out 5. I can cancel out 9. And now my k, my constant of variation, is simply 1 all over 4. So this is the constant of variation we're looking for based on the given values. And now that we have our k from our joint variation formula, we replace y, we replace x, we replace z, and now by using basic mathematics, we're able to find the unique numerical value that is present in this relationship, which is 1 over 4. And now we're ready to find y when x is 20 and z is 30. So by using the same formula, which is y equal to kxz, all we need to do now is to replace our value of x, which is 20, z, which is 30, and of course, using our constant of variation 1 over 4 so that we can find the value of y. So let's compute for that by substituting the values that we are working with right now, k times x times z. So we know that we're looking for y this time, and we are going to use the values that's given to us for this second part of the problem. We know that k is 1/4. We know that x is 20. And we know that z is 30. And by simplifying it, we'll have 20 times 30 is 600 all over 4. And we know that 600 divided by 4 is equal to 150. So now we found the value of y, given that x is 20 and z is 30, with a constant variation of 1/4 based on the first statement in our word problem. So by using our basic algebra skill and of course, the skill on how to identify the type of variation, the type of formula we're using, and how we're going to be using all those values to find y in this particular word problem, we'll be able to easily solve this word problem that is looking so complex at the beginning, but if you are going to organize your work and do it step by step, it's actually really simple. So let's start working with the second part of, or second example for the day. We have the maximum weight that a circular column can hold is inversely proportional to the square of its height. So that is going to be our first clue, which is establishing the formula that we're going to be using, and we're seeing inversely proportional. So that means we're going to be using this formula. So since y is equal to k all over z is the general formula for inverse variation, we know that in words, we say it as y varies inversely as x, given that we know the constant of variation. So if we're going to translate this form from this problem, we know that we're going to have w varies inversely as h squared. And in this case, our input and output will be represented by W and H squared. So here, our output will be our weight, or the weight of this circular column, and our input would be the height, which is given by square of its height. So this is specific to this problem, and this is a joint variation because we're using different relationship to find the value of the constant and also the equation that will be associated with this word problem. So since we have our equation now that we can use to find the value of k, all we need to do is to look at the problem and find the values that we can use so that we can find our constant of variation. So it's on the second part of our word problem. If an 8-foot column can hold 2 tons, find how much weight a 10-foot column can hold. And the first part of this second statement will be our given values that will determine our constant of variation. So we're going to be using the value of 2 tons, and we know that tons is associated with weight. So that means our W is going to be equal to 2. And we also have an 8-foot column, and we know that feet is associated to height. So that is going to be the variable that we're going to associate our value with so that we can find our constant of variation. So in this case, we're going to replace the value of our W, which is 2, the value of our H, which is 8, and by cross multiplication, we'll have 2 times 8 squared, and 8 squared is equal to 64. So if we multiply 2 and 64, we'll find the value of k, which is equal to 128. So now that we know our constant of variation specific to this relationship, we are now ready to answer the last part of our problem, which is to find how much weight a 10-foot column can hold based on the description of our circular column. And of course, its maximum weight. So we're going to be using the same formula that we were able to establish from the first part of our word problem, which is W is equal to k all over h squared. And now that we're looking for how much weight a 10-foot column can hold, that means in this particular formula, we're using our height as 10, and we're going to be working for the value of our W. Now, we know that our K is 128, so if we use this formula, all we have to do now is to replace our K, which is 128, and replace our H, which is 10, and by simplifying our fraction, we have 128 all over 100. That will give us 1.28 tons. So this is now the value of the weight that we are looking for specific to this problem. So to simply put a 10-foot circular column can hold a maximum weight of 1.28 tons based on the joint variation relationship that we are using in this particular problem. So this is how we work out problems involving numerical relationships such as joint variation. So one, you need to find the clue or the specific equation that we're going to be using, and then manipulate that equation and use the given values or data given in the word problem, and by using our basic algebra skill, we'll be able to find the variables that will satisfy this particular relationship that we are working on. So for your Numberbender challenge for the day, can you give me an example of joint variation relationship? So I have given you 3 from our lesson on the first part of our work today. So I would love to hear from you. So comment down below what specific example of real life situation that satisfies joint variation in the example that you can provide below. So that is going to be our lesson for today, joint variation. So we had 3 already. We had direct variation, we had inverse variation, and now we worked on joint variation to complete and satisfy and answer word problems involving this type of numerical relationship in algebra. So this is Dr. E, and see you again next time.